Ruang eruption on April 17 and then again on April 30. Indonesia's Ruang volcano produced powerful Plinian eruptions which absolutely devastated the 13.7 square kilometer island it sits on. Luckily, scientist warnings allowed for quick evacuations to be made, and despite every single one of the more than 200 structures on Ruang Island along with every single spot of vegetation being completely incinerated, no lives were lost. However, due to a combination of the heavy rate of ashfall which occurred alongside lava bombs and lapilli falling from heights upward of 60,000 feet, hundreds of additional structures were damaged on the adjacent Tagulandang Island. With a 7-kilometer exclusion zone still in place which is likely to remain for some time, evacuated area the government of Indonesia has arrived at a decision. Approximately 1,000 people are never to return to the most affected area, meaning everyone who formerly lived on Ruang Island. As a result, the government of Indonesia is building hundreds of homes to accommodate those displaced residents, although this will take some time. What is essentially a declaration of a permanent exclusion zone that displaces all who live within a certain radius at a volcano has occurred at least 2 other times in the 21st century in Indonesia, at Mount Merapi in 2010 and Sinabung in 2015 to 2016. This is all because the Ruang volcano has proven to be far more dangerous than previously thought, with its recent eruptive activity suggesting that a far larger magma chamber is present and even potentially an ancient caldera. While many people are still debating the exact size of Ruang's eruption which just occurred, some people asked how I arrived at my estimate of its eruption size. To answer that question, it involved estimation, a simple conversion, and eyeballing various parameters the eruption had. For example, Ruang's 2 Plinian eruptions most likely released 1.3 million metric tons of sulfur dioxide gas with estimates ranging from 500,000 to 1.5 million metric tons. Generally speaking, the amount of sulfur dioxide released is a semi-decent indicator of how much magma an eruption involved. By comparing it to the general rule of 1.3 million metric tons of sulfur dioxide being released for each cubic kilometer of tephra ejected, it would appear that around 1 cubic kilometer of tephra was released. However, my figure said 1.4 cubic kilometers, so how did I arrive at that larger figure? For that I used a conversion dense rock equivalent from the estimates the Ares account on X posted which monitors activity from satellite. They noted releases of 0.20 and 0.47 cubic kilometers of what is called dense rock equivalent, or the compact magma involved in the April 17 and April 30 eruptions respectively. I then eyeballed footage of the Vulcanian explosion which occurred on April 30 after the Plinian phase ended, giving an estimate that 0.03 cubic kilometers of dense rock equivalent was involved in that event. When you add these 3 figures together you get a dense rock equivalent of 0.70 cubic kilometers. Just so I can remind everyone, dense rock equivalent and bulk tephra figures are not the same thing. This is due to a set volume of magma producing a larger amount of uncompacted ash due to the way it forms and the numerous air bubbles tephra contains. While dependent on composition, lava versus ash andesite composition lava generally has a density of 2.6 grams per cc while andesite composition ash has a density of about 1.3 grams per cc. Thus, we multiply the prior Dre figure by 2 to get 1.4 cubic kilometers of tephra since Ruang's eruption was andesitic. As a final note, for tomorrow's video I will answer a list of questions that you, my audience, have about the Ruang volcano, its current situation, and its recent eruptive activity.